Natural language processing, or NLP, is a fascinating field at the intersection of computer science, artificial intelligence, and linguistics. It focuses on enabling computers to understand, interpret, and generate human language in a way that is both meaningful and useful. From voice assistants to translation apps, NLP powers many tools we use daily. In this video, we'll journey through the basics, applications, and future of NLP, making complex concepts easy to grasp. Let's start by exploring what makes NLP so essential in our digital world. Its core, NLP, involves teaching computers to process and analyze large amounts of natural language data. This includes everything from written text to spoken words. The process typically starts with breaking down sentences into smaller parts, such as words and phrases, and then analyzing their meaning and structure. By using algorithms and models, computers can identify patterns, understand context, and even respond intelligently. This foundational step is crucial for all NLP applications. Journey of NLP began in the 1950s, with early attempts to translate languages using computers. Over the decades, advancements in computing power and linguistic theory have propelled NLP forward. Milestones include the development of rule-based systems, statistical models, and more recently, deep learning techniques. Each era brought new breakthroughs, making NLP more accurate and accessible. Understanding this history helps us appreciate how far the technology has come. One of the first steps in NLP is text processing. This involves cleaning and preparing raw text data so that computers can analyze it effectively. Common tasks include removing punctuation, converting text to lowercase, and eliminating stop words like the and is. These steps help simplify the data, making it easier for algorithms to find patterns and extract meaning. Text processing is the foundation upon which all other NLP tasks are built. Tokenization is the process of breaking down text into smaller units, usually words or phrases called tokens. This step is essential because it allows computers to analyze language at a granular level. For example, the sentence NLP is amazing would be split into 3 tokens. NLP is and amazing. Tokenization is a simple yet powerful tool that enables deeper analysis and understanding of language. Part-of-speech tagging assigns labels to each word in a sentence, identifying whether it's a noun, verb, adjective, or another part of speech. This helps computers understand the grammatical structure of sentences and the role each word plays. For instance, in the sentence, the cat sleeps, cat is a noun and sleeps is a verb. Accurate tagging is crucial for tasks like translation and sentiment analysis. Named entity recognition, or NER, is a technique used to identify and classify key information in text, such as names of people, organizations, locations, and dates. For example, in the sentence Apple launched a new product in California, NER would recognize Apple as an organization and California as a location. This process is vital for extracting valuable insights from large text datasets. Sentiment analysis is all about determining the emotional tone behind a piece of text. It helps computers figure out whether the sentiment is positive, negative, or neutral. Businesses use sentiment analysis to gauge customer opinions from reviews or social media posts. By analyzing words and phrases, NLP models can provide valuable feedback on how people feel about products, services, or events. Machine translation uses NLP to automatically translate text from one language to another. Popular tools like Google Translate rely on advanced NLP models to provide accurate and fluent translations. These systems learn from vast amounts of multilingual data, constantly improving their ability to handle different languages and contexts. Machine translation breaks down language barriers and connects people worldwide. Speech recognition is a branch of NLP that converts spoken language into written text. This technology powers voice assistants, transcription services, and hands-free controls. By analyzing audio signals and matching them to words and phrases, NLP models can accurately transcribe speech in real time. Speech recognition makes technology more accessible and convenient for everyone. Chatbots and virtual assistants use NLP to interact with users in natural language. Whether you're asking about the weather or scheduling a meeting, these tools understand your requests and provide helpful responses. NLP enables chatbots to handle a wide range of queries, making customer service faster and more efficient. As NLP technology advances, these assistants become even smarter and more conversational. Text summarization is the process of automatically generating a concise summary of a longer document. NLP models identify the most important points and present them in a clear, brief format. This is especially useful for quickly understanding news articles, research papers, or lengthy reports. Summarization saves time and helps users focus on the key information they need. Text classification involves sorting text into predefined categories. For example, emails can be classified as spam or not spam, and news articles can be grouped by topic. NLP models analyze the content and assign appropriate labels, making it easier to organize and manage large volumes of text. This technique is widely used in email filtering, content moderation, and more. Question answering systems use NLP to understand and respond to user queries. These systems can search through large databases or documents to find relevant answers. For instance, virtual assistants can answer questions about the weather, history, or company policies. By combining language understanding with information retrieval, NLP makes it possible to get quick, accurate answers to a wide range of questions. NLP relies on a variety of algorithms to process and analyze language. These include rule-based methods, statistical models, and deep learning techniques. Each approach has its strengths and is chosen based on the task at hand. For example, deep learning models excel at understanding context and generating human-like text, while rule-based systems are useful for specific, well-defined tasks. Deep learning has revolutionized NLP by enabling computers to understand language at a much deeper level. Neural networks, especially models like transformers, can capture complex patterns and relationships in text. This has led to significant improvements in tasks like translation, summarization, and question answering. deep learning continues to push the boundaries of what NLP can achieve. Despite its progress, NLP faces several challenges. Human language is full of ambiguity, slang, and cultural nuances that are difficult for computers to interpret. Sarcasm, idioms, and context-dependent meanings often trip up even the most advanced models. Researchers are constantly working to improve NLP's ability to handle these complexities and make language understanding more robust. As NLP becomes more powerful, ethical considerations are increasingly important. Issues like bias in language models, privacy concerns, and the potential for misuse must be addressed. Developers and researchers are working to create fair, transparent, and responsible NLP systems. Ensuring that technology benefits everyone is a key priority for the future of NLP. NLP is all around us, powering tools and services we use every day. From voice assistants and chatbots to translation apps and spam filters, NLP makes technology more intuitive and user-friendly. Its applications are constantly expanding, making our interactions with devices smoother and more natural. The impact of NLP on daily life is only set to grow. Future of NLP is incredibly exciting. Advances in artificial intelligence and computing power are opening up new possibilities, from real-time translation to more human-like conversations with machines. Researchers are exploring ways to make NLP models more accurate, efficient, and ethical. As technology evolves, NLP will continue to transform how we communicate and interact with the digital world. Summary: natural language processing is a dynamic and rapidly growing field that bridges the gap between humans and machines. From understanding text and speech to powering intelligent assistants, NLP is transforming the way we interact with technology. As we look to the future, continued innovation and ethical development will ensure NLP remains a force for good, making our digital experiences richer and more meaningful.